In this unit, we have studied acceleration of electrons by electric field and magnetic field. And we have also studied this acceleration under various cases. Then we have studied electron gun. CRO is the advanced part of electron gun with additional features. We have studied lens, how lens can be prepared, electrical lens, magnetic lens, and so many things. Now we will discuss cathode ray oscilloscope, how it can be used to move electrons on the screen in a better way. The aim of this lecture or the learning outcome, in the end, you will learn how electron can be deflected by using deflection plates and how we can see signal on the output. As we deal with AC signals may have different shapes. The shapes can be visualized here. CRO basically is to visualize signals. So we will learn about this. Then we will learn details about block diagram, various parts, functioning of each diagram, each block, and finally we will discuss applications of CRO. CRO. CRO is also called sometimes as engineer's eye. Engineers can visualize what is happening in a particular circuit area in a network. It is similar to multimeter in a way that it can measure voltage, current, and so many things, but it has additional feature. You can visualize. Oscilloscope is used to visualize the signals, whether the signals are coming properly or it is stripped. This can be checked here. Wave shaping, then clamping, clipping of the circuit signals can be checked using this CRO. CRO is very useful for engineering point of view. Cathode ray oscilloscope, or in short CRO, is used to measure electrical signals, time interval, phase shift between electrical signals. The internal section of an oscilloscope can be divided into 7 major parts. These 7 parts are here, and we will show these 7 parts in a block diagram also. First one is, and most important, is CRT, cathode ray tube. We have discussed this in detail. Then to add signal, another thing is time-based circuit. And to synchronize these two, we have used trigger circuit. Then we have vertical circuits arrangement. Then we have horizontal circuit arrangement, and of course power supplies. High voltage power supply, low voltage power supply, and so on. The block diagram is shown here with the 7 parts. everything is shown here. This part is your, this is your, what is this? CRT. We have discussed this CRT in detail in the last. Screen is there, electron beam is there, then luminescence spot and deflections plates. Two set of deflection plates. Here we have shown only Y plates. Then electron gun and X plates is here. This is X, yeah, separated by some distance. Now we have high voltage power supply and low voltage power supply. Then triggered circuit, time based circuit, horizontal amplifier, everything is here. First and most important part, which the specific particular portion of this part is also visualized to everybody, even to layman, that is CRT, cathode ray tube. We have discussed cathode ray tube in detail in the last lecture. We have devoted one specific talk on this. Cathode ray tube basically is a with electro diffraction is there. This form the central part of CRO. The high voltage power supply section provide high potential to these electrodes of cathode ray tube. The CRT generates electron beam, focus it and accelerate towards fluorescent screen. So basically the basic thing is you need electrons and the electron are generated in this CRT. After generation, the second question is focusing. So it focuses the things by anode arrangement, and then we have deflection circuits. So finally it reaches to, using deflection, it reaches to screen. The CRT generates the electron beam, focus it and accelerate it. The rest of the section are electronic circuit which cause the desired movement of the luminescent spot on the screen. We have two movements here, vertical movement and horizontal movement in this. In the field of electronics, the message in an electrical signal, the signal is applied to Y plates or vertical plates. When the signal voltage is applied to vertical plates, the polarity and magnitude of voltage plates vary with each alternation of the cycle. As a result, the spot moves up and down on the screen. The phosphor continues to glow for a short time after the electron beam passes, and due to the persistence of vision, the path of the beam across the screen is seen as vertical line. So you can't see single points, you can see vertical line. This is called trace. The length of vertical trace correspond to peak voltage, VPP. The details of the signal are not revealed through this vertical motion. The signal form can be shown only when the beam moves horizontally. Actually, the important thing to note is vertical movement is used to feed the signal. The signal that you want to see, we feed the signal on these vertical plates. The signal is generated by the cathode ray source and will move from these vertical plates. So it will move in up and down. How much voltage is applied? This can be seen using VPP, peak to peak, and length of this trace. But the limitation, suppose we don't have a horizontal plate, then the limitation is you can't move the signal. You can see only top and bottom, maximum top and bottom. Horizontal move is not there. Since the question is you are applying a signal, you are getting only top and bottom single line. Why? Because it is not moving on x direction. If you want to feed x direction, you have to use the second set of plates. These are called horizontal plates. The horizontal motion of the electron is produced when an AC signal is applied to X plates in the signal. In a signal, the voltage varies as a function of time. The electron beam gets deflection through equal distance per unit time when voltage is applied to X plates and increases equal moment of voltage with respect to time. At the end of the horizontal motion, the beam returns to the original position. We have to synchronize these two signals, X and Y, number one. And second thing is, the X signal is used to feed time axis. So something, whenever your signal is, you are applying your signal on Y axis, your time motion should be there in one direction. So we use a specific signal here, which always move in one direction during you are applying signal on Y. And then suddenly move to original position. Can you guess which type of signal it is? Yes, this is called time-based circuit because this add time axis in the signal. So this is called time-based circuit. Time-based voltage. The voltage that we apply on X plate is called time-based voltage. To display the signal to the Y plate, it has to be horizontally moved or swept by the voltage. So we use this voltage, and this voltage, particular voltage, is called ramp voltage. It's a kind of a ramp slope. This is also known as sawtooth voltage. You just see the rhythm here. This is similar to sawtooth. I think all of you may have seen the sawtooth. Sawtooth is just like this, a cutter sawtooth, which fulfill this response. This is called time-based voltage, this is called ramp voltage, this is called sawtooth voltage. Sometimes by this special figure, you can also term it as it is a triangular voltage. This is time-based because it to feed time in the circuit. Triangular, you can see this. It moves from 1 to 5 in a long time. In almost all cycle, it is moving from 1 to 5 in almost all the time in the same direction. But suddenly move to 5 to 6 and then 7. 5 to 7 is almost negligible, but 1 to 5 is long. Special kind of voltage. The time-based circuit mainly consists of time-based generator. The time-based generator is a variable frequency oscillator which produces above mentioned ramp voltage. Ideally, the voltage increases with time for a negative value to a maximum value and then suddenly drop to minimum. Something interesting to note, this is moving in forward direction and then this is moving in, and this is very small, this or this is very small, immediately go to this. So in forward motion, this is your forward motion moving like this, but this is your backward motion straight. Now we will discuss display of signal. As the signal is applied to Y plate and the time-based voltage to the X plate, the electron beam is subjected to two forces acting perpendicular direction to each other. Due to your signal, it will move in vertical direction, as due to time base, it will move in X direction. So finally, the electron will move in a resultant of these two. The deflection of beam at any instant occurs along the direction of resultant of two forces. As the time progresses, the resultant change in magnitude and direction and beam display the actual shape of the signal on the screen. The process is given here. Interestingly, suppose here we have shown the position of Y signal, position of X signal, and the position of screen. If on the left first we have shown position of Y signal and we have applied this signal. This is the name of this signal is sinusoidal signal or sine wave, which is continuously first it is increasing from 1 to 2, then it decreasing to 3, then it's moving to 4, then again increasing to 5, then 6, and then 7. This time the signal that you have applied on x-axis is this. The signal 1 to 5 is in one direction. You just check this. Here this is moving in same direction all the time. Then 5 to 6, 7 is in a very small time. So what will happen? If you are not applying anything, you will get only a single line. This single vertical line if you are not applying anything. But if you apply your signal, then you will get this axis also. And if you apply both the things, then the signal will move in this way. Suppose you are applied this X signal, your signal on Y, and on X you are applied this signal. Now the second signal will continuously push your particle in the forward direction, and for upward and downward direction will be get by first signal, which is on Y. So similarly, if you do this, you will get the output like this on outer side. One very interesting knob is also there with the CRO, that is known as triggered circuit. Now this is shown that you are applying one signal on y-axis, and to feed x-axis you are applying another signal on x-axis. Now the thing is, who will synchronize these two? There is a possibility that x will be first and y will be second. There will be possibility y will be first and x will be second. You have to synchronize these two. But since you are applying two things from different sources, synchronization is important. And then synchronization is called trigger. I think all of you are aware with this. Whenever we use any competition like athletics or something, we always use our trigger. Who will start the process at the same time? Suppose 10 persons are participating in one athletic competition. Then triggering is you have to push something, you have to shout, or you have to whistle something. That's called triggering. This type of circuit we also use in CRO to display a stationary wave option on CRO, the horizontal deflection plate should start at the same time or should close at the same time. This is important. Should start at the same time of the input in each swept circuit. When this happens, we say the horizontal sweep voltage is synchronized with input signal. If the sweep and signal are not synchronized, a pattern will not be displayed. One of the methods to achieve synchronization is using trigger circuit. In this method, a small part of your output obtained from vertical amplifier fed to triggered circuit. Means whenever you start vertical signal, a small part of that signal will move fed to trigger generator, and trigger generator is very sensitive to the level of voltage applied in the input. When trigger circuit will open, it produces a pulse, and we send the pulse to X time-based generator to give the output. The signal is synchronized when frequency equal to sweep frequency. Signal frequency should be equal to sweep frequency or an integral multiple of sweep frequency. Sweep frequency is the frequency for this time base and signal frequency that you applied. For example, T sweep is equal to T signal, one wave will be displayed on the screen. If T sweep is equal to 2 signal, 2 wave will be displayed. So that is important what we need to display. We have discussed two important sections, CRO and triggered circuit and time-based circuit, deflection plates. Now, some other are vertical circuit. The vertical circuit mainly consists of attenuator and a voltage amplifier. The signal to be tested in vertical biput, the signal is amplitude is increased or decreased by changing the attenuation. So this circuit is used to increase or decrease the signal voltage so that adequate deflection is obtained. Horizontal circuit similarly consists of an attenuator and a voltage amplifier when the sweep selector switch is in position. The sweep voltage from time base is applied to amplifier to external position. The horizontal input is disconnected from the internal sweep generator and connected to X. Low power and high power supplies are also there. Low power is used provide power to electrical circuit like amplifier, trigger generator, time base. Everywhere we use low power except at one place, generation of electron, where we use high power. The order of low power is few hundred of volts, 1/10, few tenth of to few hundred volt, whereas for high power this voltage is 1600 volt to 2200 volt, very high power. This power is used to generate electron ray. So in this lecture we have studied CRO, functioning of CRO, various parts of CRO. It may be asked as give a block diagram of CRO and discuss various functions. In the next lecture we will discuss applications of CRO.